So the next thing we're going to talk about is have a look at several formats. And the first format we have is a Go only format. This is known as GOB. And I think it's short for Go binary. And we assume that we have some kind of a trade object that has a time, has a symbol, has the volume, how many stocks were bought or sold, the price that we bought or sold them, and if it was a buy trade or a sell trade. So did we buy the stocks or did we sell the stocks? Okay, this is a real stock, by the way. One stock is around $320,000. And when you work with GOBs, you don't need to do anything. GOBs support most of the Go types out of the box. You don't need to think about time or anything or Boolean values or anything. You just encode and decode, and it's going to work. But as I said, it's Go only. So if you have services running with Go, you can just send GOBs all over the place. You don't really care about schemas, about what types are serialized or not, and it will work really nice for you. The second one is JSON, right? JSON is a very well-known format. And we see here that the time is serialized as a string because JSON does not have support for a timestamp type. So we need somehow externally to know that this is going to be a time, and we need to convert it back to time when we unmarshal or deserialize it, depending on what's going on. Two formats that are very, going back to JSON. JSON is very popular. It's a good default choice for a serialization format. But as I said, it doesn't support time. And when you come to configuration and other things, it doesn't have comments in the format, which makes it really bad for configuration. So if you're doing configuration, try not to use JSON. It's really, really annoying to have configuration without comment. And what is really common, in the world of configuration is YAML and TOML. These are two formats which are also textual. They are highly human readables. They have more types than JSON, and they do support comments. So you can use them there. XML, sorry, hold on. So XML has been around for a while, right? It got a bad reputation because when it came out, people did a lot of crazy stuff with it, including backing up databases to XML and many other things that you shouldn't do with XML. But it is out there. I can almost guarantee you that at one point or another, you are going to work with XML. So XML is a tree-like. It does not have types associated. So when you read time and when you read price, it is going to get back to you as a text. And you need somehow externally to know the time is actually a timestamp and that the price is actually a floating point number. There are external things like XML schemas and DTDs that you can work with to know how to convert these types. But it's not a pleasant thing to work with, but and it's in the standard library. So it's there, it's for you to work with. Another very popular format is CSV. CSV stands for comma separated values. And people really like CSV because you can export and import from Excel, which makes it a data for exchanging some data between a lot of services. It is very popular format. I hate it with a passion. Really, it's a really bad format. There's no standard for CSV. So everybody is agreeing or something, but there's no spec like for JSON or for XML. There are no types. So again, everything is textual in CSVs. If you have the misfortune of working with Unicode inside CSVs, that's a world of pain. It is out there. You will probably touch it at one point or another, but if you can avoid it, I highly recommend it that you don't. Protocol buffers. Protocol buffers is a binary format. It is coming from Google. It has a schema. So we define a message, and these are our objects. And we say that the time is a timestamp, and there is a built-in type called a timestamp inside. There are strings and integers and doubles for values, etc., etc. And what happens in protocol buffers is that you write this definition file, and then you call a tool called proto-C, and we are going to do that, which is going to generate binding for a language. So we're going to generate bindings for Go. But the nice thing is that if you have several microservices, you have the same protocol buffer definition, and you generate the bindings or the definition for every language. So all the microservices agree on the same format. It's not like JSON when some service that is producing the data decided to change a field, rename it or add it or delete it. Then all the other ones, they might know it, they might not. The schema is the same for everyone. So you generate for all the languages. It's pretty performant and has a lot of tooling and knowledge around it. Another format which is used a lot is SQL. Right, so SQL databases, they invented the notion of schema. And there you find columns. So I have a column of time, which is timestamp, and the symbol and the volume and the price and the buy. I've used, and database SQL is again inside the standard library, although the drivers, the specific driver per database are coming from external resources. I've used SQL a lot of time to exchange big amounts of data. There is a database called SQLite, which is embedded database. If you're using an Android phone or a web browser, you are using SQLite. It is really heavily used all over the place. And I used it, I had one service in Go that was writing to an SQLite database. And once it was finished, it was just pinging another Python service saying, look, the data is in this file, and the Python could start working on the file. So you can stream a lot of data into the SQL. You can do queries. You can do a lot of interesting things with SQL. So if you have streaming data and you want to support queries, SQL is an interesting thing to look at. And SQL is supported in Go as an external dependency. And apart from that, there's message packs and flat buffers and Captain Proto, Parquet, Orc, HD5, Arrow, and you name it. There are many, 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 many other things. The only thing I ask is, please don't invent your own. There are enough. Trust me, there are too many as is. So whenever you need some kind of serialization, don't invent your own. And sometimes it happens even without thinking. So here's a library called event config, which basically takes configuration values and put them inside a Go struct, and it supports several types. So if you see at the bottom there, it supports Boolean values as false or true, and integers as 8080. But then when we get to the bottom two, he invented his own format for lists and maps. Instead of saying, let's say, the list is a JSON list and map is a JSON object, and then you have an established format. It's already debugged. You don't have issues. For example, what happens in the map if I have a column inside the value?